In this channel, we have shown you previously how to use data science to create cool projects like what makes and predicts a song will be popular on Spotify, how to make a winning football team with a low budget, like in the movie Moneyball, or predict if someone will develop diabetes, taking into account multiple factors like their age, gender, height, BMI, number of pregnancies, and so on. If you want to learn how to make this type of analysis, you will probably need to learn a programming language like R or Python. So, in this video, I want to prove that with new tools like Graphext, you can not only replicate this analysis without writing a single line of code, but how these immersive and visual new user interfaces are even more powerful than writing code on a Jupyter notebook. And to prove it, I'm gonna make the same example that Rod Mula made on his YouTube channel called Exploratory Data Analysis with Python and Pandas in 2023, link below. So I'm gonna follow step by step Rob's notebook so that we can see how this is done with Graphext instead of with Python. First thing, we go to the roller coaster notebook, which is linked on Kaggle below. You can find the link and also on Rob's video. And the first thing we find is this section, this tab called 0, imports and reading data. We can see how he's basically importing multiple libraries like Pandas, NumPy, Matplotlib, Seaborn. They serve multiple purposes. Some of them are for data wrangling, data cleaning, like Pandas. Others, like Matplotlib or Seaborn, are specified for later doing some type of data visualization. Okay, so the first thing is actually importing the CSV. I downloaded the CSV that can be found here. If you click on the roller coaster database, you can download it from Kaggle as a CSV. So then I go to Graphext, and what I'm doing is I'm uploading this CSV simply by creating a new project, clicking on browser file, and finding the coaster DB CSV. There you go. A new project will get created. This will take a few seconds to show the preview of the data set. In the meantime, we can open it, and as soon as it's imported, we will see it. There you go. This is the data set, and we can see a preview not only of a few hundreds of rows, but the whole thing. So going back to Rob's notebook, we can go now to step 1, that is data understanding. We see how he's starting with a data frame shape that functions will return the number of rows and the number of columns. And then he does a df head 5 that's returning the 5 top rows on the data sets as an example. At this point, he needs to go back to the beginning and change these parameters, mass columns, to 200. That's a parameter that will allow you to display here up to 200 columns. By default, Pandas is not able to display more than that. So how do we see that in Graphext? Very simple. In Graphext, automatically, you don't need to do anything because you always see here on the top left, like what is the number of rows and what is the number of columns. And then you always see like the whole thing, the whole data set with as many variables and as many rows as you have, like up to many millions and up to hundreds of columns if you need it. Then we see Rob's is checking with data frame columns, just simply listing the names of the columns that we have in the data set and the data types. And also with describe, he's getting the median, standard deviation, the quartiles, the maximum numbers, etc. for each of these variables. So in Graphext, this is even better as well because we can simply magnify this, and we not only see all the variables that we have with their names and data types, but we can also see the distribution automatically. And in case we have like let's say, for instance, the speed, we click on this icon and we get all the same measures that we described: the minimum, the quartile, the median, the maximum, etc. So now step 2, data preparation. He's starting by dropping irrelevant columns and rows. We can see how he's showing you how he's dropping in opening date as a variable, and he's now also hiding other more irrelevant columns that he's not going to use in the later for analysis by introducing comments. from my point of view, this is too bad because like, how do you know which ones you want to hide if you're not able to see them, the distribution at the same time? Um, and then he's casting a data into like a data time, like opening data clean. So let's see how to do this in Graphext. So let's look for opening date. This one. Okay, so he's removing it. So there's two ways we can remove it in Graphex. One is remove it, or we can also hide it. Okay, so if we want to hide it, we will go into variable manager, and now we are able to simply hide it. I prefer hiding actually. The other, so he's done it. He has done it with many other of these variables that he cleaned it previously. Like length is later in numerical variable, so he does it like this. As you can see, Graphics is very visual because you see actually like the distributions, and that's very handy to make that decision. Um, and yes, you can go one by one. And when you're ready, you simply hide it. Okay. Um, we also saw that he's casting opening date clean into a date. So if we go into opening date clean, we see that Graphex automatically inferred this field as a date variable. So we don't need to cast it. Sometimes we fail, and not very often, but sometimes we do. And if we fail, you can cast any data type like this. So you simply need to click on the new data type, and you will see a preview. And if you are fine, if you like it, you can save it, or you can stop saving it. Okay. So now I see he's basically here renaming some columns, changing, showing you how to change the name of the columns. And here he's simply also presenting how many null variables how many null values we had for each variable. In Graphex, renaming a column, super easy. You go here and basically say, okay, this is instead of cluster name, I'm gonna remove the space and make these letters capital letters. Save it. There you go. About the new null values, we always display this bar when there is null values. If there is no bar, that means that 100% of the rows of the observations have values. But for instance, for status, we see that we have like 213 null rows. That represents around 20% of the values. Same thing for others, and we can easily see that. Now we see that Rob is using this function df duplicated to search for duplicated values. Apparently there are not any, and that's very normal because, you know, like in most databases, is something that they automatically check and make sure of the integrity of the data. But in any case, I mean, we have thought about that as well. So, and it's a good opportunity to show you the low code of Graphex, because we are no code, but we also implemented a low code language that makes things very powerful. So you go into the recipe, you click on the text editor, and if you start typing duplicate, you'll see that there's a filter duplicate functions that takes the current data set and creates a new one. I'm not gonna run it because we saw and we know there's no any duplicate. And I mean, this low code will get translated into something that will be blocks for doing other functions for data wrangling, and this is coming very soon to Graphic, but it's still not completely ready. I also saw that apart from not finding duplicates, he's trying by like looking for cluster names with the same name and see whether there are duplicates or not, taking into account the year introduced. So we can do exactly the same thing. So if I click on La Vibora, for instance, I can see there are 3 instances of La Vibora, and apparently they are all the same because they have the same length, the same speed, the same type, and everything. So if we go to the year introduced, we see that they were introduced in different years, and that's why they are not duplicated. Okay, maybe they close it and reopen it or something like that, and that's why you find it that way. That is I think is what exactly he explains on the video. Okay. So now let's jump into the most fun part, the step 3, feature understanding with univariate analysis, like going one variable by one variable, right? So on this part, he's starting with simply doing an histogram of the variable year introduced, and he's counting the number of instances by year. Uh, and then he's simply adding a title to the chart, top 10 years coaster introduced, and year introduced and count. Okay. So if we go to Graphext and search for that variable year introduced, we'll see that we actually plot automatically the plot. I can open it in plot, so I have more control. And we see that automatically Graphex is detecting these are years and is putting it by in a way that we see the trend, right? And we can see like around 1999 more roller coasters were introduced, right? And in the year 2000. Um, we can aggregate this in different levels. So you can see by 10-year, for instance, right? Or by quarters or by month, right? Depending on the granularity of the data we have. Okay. And then if we want to add that title, we simply need to go to the customize section and then on the chart title, adding the same title that they added. I think they also modify the default names that we had for count. We say count of nodes, but you can simply say count. And instead of year introduced by year, you can simply say year introduced. Once you have that, you can save that in Graphex as an insight just by clicking on Save Insight, and this will get saved on this section. Okay, this is like kind of like a PowerPoint presentation that you can create and start adding more comments here on the right, like at the end of the century there was a fever for roller coaster, right? Simply save that. And then if anyone that I share this project click on play, it will bring them to the same insight. And of course, you can also export this as an image if you want to do it, clicking on that export section. You can also style it with many different colors and styling, and we will allow you to do even more of this customization with more and more options that we are adding pretty soon. Okay. And then we see that he is doing something similar, but in this case with a numerical variable, speed in miles per hour, and with a KDE. Yeah, so let's try to do something similar. So speed, miles per hours. I mean, we don't have KDE, but it's pretty similar to a line chart. You can define the bin size, and you can get a very similar chart. He adds also a title. We already saw how to do that. So yes, I mean, I basically leave it like that. And then she's showing the type main that for it here. Oops. Here we see like the same number of instances that he's seeing for each material. So let's go now for step 4, feature relationships. This is about understanding pair of variables, how they're related, how they're correlated. And he's starting with this specific example of a scatter plot between speed in miles per hour and height in feet. Okay, so adding this title. So let's go to Graphext. So it was speed and the height. We don't have scatter plots yet. This is coming very soon. It's in the oven right now. So I will use box plots because they are very similar in Graphex when I add more and more bins. So you'll see now that this is essentially showing a data point when you only have one value count. And if there are multiples, we kind of group them into these bars that show like the deviation and everything. If you see like the other chart, you'll see that is almost exactly the same, right? That you have this outlier over here and this other, right? And we have it in the same chart. Again, adding the title, super simple. Go here and add it there. Okay. I will save it as an insight as well. So I can go and check it there and also see other insights that I've been saving as well. Um, the next one, no, now what he's doing, he's coloring the nodes by the year introduced. So this is something that since we don't have real scatter plots yet, coming very soon again, uh, we cannot do it right now. But we can do something instead that you cannot do with a Jupyter notebook that I think is very cool. Let me go to the data and sorry, plot. And now I'm gonna go into explore mode and year introduce. So something that I can do is that interactively I can filter by this. So I can select like a range and I can move it. And immediately I see how this is reactively uh, drawing the different data points that we have for this different time period. This is super interesting and very often it's a much better way than coloring the nodes, okay? Depending on the nature of the data and the categories that you have, okay? You can also color by this, like, hey, by the manufacturer, right? You see? Super interesting, right? Now he's looking at multiple relationships between different variables using these seaborn functions called bear plot, where he's plotting the relationships between all of these numerical variables that we have in the data set. And then later, he's also showing like the degree of correlation between the numerical variables as a matrix and plotting that matrix to see what pair of variables are more related. So the way we do this in Graphext is a little bit different, more powerful. Why? Because he's only using, in this case, the numerical variables. And very often we'll see that in real life, most companies have more categorical variables and numerical variables. And if you want to understand like correlations between categorical and numerical and categorical and categorical, a simply correlation that you apply by default won't work. So we implemented something called correlations, and we use mutual information that is a different score than the typical Pearson correlation that is able to work with these categorical data types. So for instance, if I go to the speed miles per hour, I can see that that's telling me that it's highly correlated with the manufacturer, which if you think about it makes sense because different manufacturers will be specialized in different roller coasters that will be able to go at different speeds, right? So I can see, for instance, that right that in Tamin is the one that is able to produce like the faster roller coasters, right? Um, if we go back to the example here, you won't find that insight because again they are not able to work with that categorical variable. Okay. What is nice about Graphex is that again we also use the other relationships, right? Like the numerical relationships. And when you see this, you can also open it in plot and visualize in many multiple ways. So here you are seeing like what number of roller coasters are from what manufacturers and go to a certain speed, okay? And you can play with all these different parameters to find different relationships, right? So and this is super useful. And then using the same relationship, I can go back here and this is gonna suggest me uh, what are other charts that I could see, like for instance, like what manufacturers produce the faster uh, average roller coasters. Like in this case, it's Morgan Manufacturing. They have 9 roller coasters, and the average is 73.8. I could switch it to the median, and I can see that the Sensei Technologies actually is the fastest one. That is the one that we saw, I think, here, right? No, it's not that one, but that one is also very fast. So that's one thing. Another way we can compare multiple relationships between multiple variables is through compare. Okay, so compare, I can pick exactly different segments. In this case, I'm checking again the manufacturer, and as you see, as I add more and more, this is showing me in a different data visualization how they compare to each other. Okay. Again, this is very, very visual, and it makes so much easier when, because often you only to focus on specific segments and all, not all of the segments. It will be very, very common to say, hey, I really want to just compare like what differentiate the most, uh, let's say this location, let's say Cedar Point with Kings Island. Okay, so I can see that there are faster speeds in Cedar Points, right? For instance, and again, any of these things you can save them easily as an insight, and you can also filter by groups of variables that you have designed. For instance, I created just like a few parameters that are about the design properties of the roller coasters, and I can see how that's related with the speeds, right? Like for instance, uh, inversions or the duration and all that. And finally, step number 5, ask a questions about the data. Okay. So here what we're seeing is he's trying to answer the questions, what are the locations with the fastest roller coasters and with a minimum of 10 roller coasters in the same theme park. Okay. So we see how he's trying to, avoid having the other answer. He's grouping by location, and then he's adding the data from the speed, miles per hour. Then he's aggregating by the count and the mean, and then he's querying and filtering by the count more than 10. And he's sorting the values and whatever. So you see, you need to do like many multiple steps with a syntax that I tend to forget. Every time I need to do this in Python, I need to go and Google and Stack Overflow and remember. Maybe now the ChatGPT and others can help us with Copilot to deal with this. But still, it's like it takes a lot of time to ask simple questions like this one. So how do you do that in Graphext? Very easy. You go here and search for location. Okay. And then I open this in plot. Okay. And then we see how many instances we have for each location. And then I simply need to map here the speed. Okay. And by default, we give you the average. We can put the median. Okay. And now we can remove anyone that is above 10. Okay. So I can see that here these uh, values are about 10 from World of Fun. So I'm gonna filter here these values. There you go. Uh, so that's it. These are the fastest by the median or by average. I think he did the average actually because Busch Garden Williamsburg is the same value, I guess, that from here, right? Busch, 0 point, exactly the same thing. And I'm gonna go and save it as an insight. That's it. Easy, right? I hope you like it. There are many different things that I didn't show that you can actually do to do much deeper analysis and even creating predictive models. If you go to the wizard, you'll see that there is this section called models where I could create and predict, let's say, the speed, for instance, right, of the roller coaster as a target, and adding all the things like the height, uh, I don't know, like the inversions and others as factors. And Graphex is automatically creating for you a predictive model that I'm not going to go into that. That's going to be in a separate episode because I really wanted to stick just to the content that Rob created with exploratory data analysis. This is more predictive modeling that is totally connected and is part of Graphex, but we will do it in a separate video. If you like it, please go to our website, graphext.com, and sign up for a free account. We had free accounts. You can totally do what I did with the free account. The only limitation that we had for the free account is the number of rows that you can work with. In this case, this was a very small data set of only 1,000 rows, but with the free account, you can get to up to 4,000 rows. And if you work in a company and you need more rows and you need to connect to the data warehouses and so forth, we have the pricing page that you'll find that is quite cheap if you take into account all the time that we save, all the power that we add. And yeah, I mean, please also check out Rob content. He's great. He's an amazing communicator. He does amazing job. We're not against Python. We use Python all the time. Graphext use these functions behind the scenes. So I mean, that's it. Thank you. See you next time.